Hi, I want to make 3 short videos about quadratic functions. I want to make a video. In this video, I'm going to explain what a quadratic function is. And then in 2 other videos, I want to explain how to factor quadratic functions and then how to use the quadratic equation to solve quadratic functions. There's a lot here. This can get kind of complicated, but I just want to keep it as simple as possible, which is why I'm breaking this up into 3 different videos. In this video, I want to talk about what a quadratic function is. What is its definition? What's unique about it, and then how do we work with it? How do we talk about quadratic functions? So in the top left of the screen here, I have a sort of the basic form, the raw form of a quadratic function. And the unique thing about quadratic functions, as you can probably see by this, they will always have 3 terms, or not always, but they typically will have 3 terms: ax squared, bx, and c. 3 terms here, and we use the coefficients in a quadratic function more than anything else. We're really going to talk a lot about the coefficients here. A is the coefficient in front of x squared. B will be the coefficient in front of x, and C will be kind of the lone term that doesn't have a variable. So sometimes they might be written in a different order. X might come before x squared, but A will always be the coefficient in front of x squared. B will always be the coefficient in front of x, and C will always be the term that does not have a variable. So when I'm looking at the quadratic equation, for example, you might see a bunch of A's and B's and C's. This is what we're talking about. If you are looking at the formula sheet that you're given for the GED math test, you'll see the basic form of a quadratic function, which is ax squared plus bx plus c. Sometimes we might refer to this as a trinomial because it has 3 terms. But that's kind of what's unique about this. And we're going to be talking about A, B, and C a lot in coming videos. Another unique thing about a function is how it looks on a graph, or about the other unique thing about a quadratic function is how it looks on a graph. So typically, if you're graphing a line, it's, a straight line is pretty simple. My line isn't perfectly straight, but you can have a line with a positive slope. You can have a line with a negative slope like this. And those equations are going to be pretty straightforward. Y equals mx plus b. There's not going to be any x squared. It's going to be 2 terms at most in your equation. But when we start working with quadratic functions, things get a little bit more complicated, because now instead of this graphing as a straight line, it's going to graph as a curve. So it's gonna look like this as a curve. It also might, let me do one more color. It also might look, it can look like a frowning face. It can look like a smiling face. It can look like any of these things. So when we're graphing a quadratic function, it's going to end up looking kind of like a curve like this. Now the interesting thing about a curve is it crosses the x-axis in 2 different places. And even though it's a curve, it's still a function. For each x value, there's exactly 1 y value. But you'll notice that here it crosses the x-axis at about positive 14, and here again at negative 7. All right, so here you see this curve crosses the x-axis at positive 14, crosses the x-axis again at negative 7. So a lot of times when we're using the quadratic equation, or when we're factoring quadratic equations, we're going to come up with 2 solutions. And those 2 solutions are the 2 places where the graph crosses the x-axis. It's helpful to have that information because it helps us graph. Once I know the two places where the curve crosses the x-axis, I can find the vertex, which is the highest or lowest point, and then I can graph the rest of the curve from there. So it's helpful when we're starting to graph to find those two x-intercepts. Which is why, when we use the quadratic equation, when we factor later, we're going to come out with two answers. So real quick, I want to look at a couple other quadratic functions, and I just want to identify a, b, and c, what the coefficients are on these other quadratic functions, so that we can start to do these other processes. So here's one more, and think about what is a, what is b, and what is c. With this, you see three terms. Remember, a is the coefficient in front of x squared. So here a is going to be 1. B is the coefficient in front of x, so b will be 2. C will be the term that's kind of by itself. It doesn't have a variable attached to it. Here's going to be negative. Oops. It's going to be negative 3. So when we're identifying C here, and really any other term, if it has that subtraction sign in front of it, the term is going to be negative. So with this particular quadratic function, the value of a is 1, the value of b is 2, the value of c is negative 3. Let's look at two more examples. In this example, I want you to identify a, b, and c. These three values for the quadratic function. So go ahead and pause the video a second, try to write these down. Once you've found them, hit resume and check your answers. So if you did that, we're checking your answers now. If you didn't and you're just watching, that's fine too, I guess. But A, you should get positive 2. Positive 2 is the coefficient in front of x squared. B should get positive 4, and C, the term by itself, should be positive 2. Those are your A, B, and C for this quadratic function. Let's do one more example together. Y equals x squared plus 2x plus 1. So try to identify A, B, and C. Again, you can pause the video to identify these if you would like. And if you've done this, you should have 1 as your coefficient with A, 2 is B, and C is positive 1 also. So here with x squared, there is no visible coefficient in front of x squared. Anytime you have a variable by itself that doesn't have a visible coefficient, you can assume that there is an invisible 1 right there. So anytime you see x squared by itself, or if you see 2x by itself, those coefficients would be 1. So we've talked about kind of what a quadratic function is, how it looks on a graph, why we're going to end up with two solutions when we start solving these, and we talked about how to identify A, B, and C of a quadratic function. In the next video that I'm about to make, we'll talk about factoring quadratic functions and how to solve quadratic functions using that method. Thank you.